Okay, so we're moving into a new section. We're going to talk about solving systems of equations. So there's going to be um, 3 or 4 different ways that we can solve systems of equations. And I'm going to teach you how to do one of them today. This is probably the easiest method, so long as your equation is in this y is equal to mx plus b form. All right. So if it's not in, if both of your equations are in y equals mx plus b form, this is probably going to be one of the easiest ways to solve it because it just involves graphing the lines. All right. So the goal here is instead of looking at a function or looking at what the lines look like on the graph, we want to figure out what x and y are equal to. We want numbers. We want x is equal to 1 or 7 or 12. Y is equal to 1 or 7 or 12 or whatever number it is. We want a x is equal to some number, y is equal to some number. That's our goal. All right. And in order to do that, the rule for equations is you need an equation for every variable that you have. So if I have one variable, I can solve it with one equation. If I have 2 variables, I can solve it with 2 equations. If I have 3 variables like x, y, and z, then I need 3 equations to solve for the unknown. All right, so that's kind of the rule. So with systems of equations, we're going to get 2 equations and we're going to have 2 letters that we don't know, and we're going to try to solve them like we did before and get a number for these. So that's sort of the goal that we have. Let's look at how we do this. So this example is solving systems by graphing, and it only works well if it's in y equals mx plus b form. So what we're going to do to solve for x and y is basically we're going to plot both of these lines on this graph, and we're going to see where they intersect. Where they intersect is going to be the solution to these equations, okay? So remember to graph these lines. Remember that the number on the end, that tells you where you cross the y-axis, so that's where you start. So this line, if we're graphing it, is down 3 because it's negative 3. So there's our first point. All right. And then we use the slope to find other points on the line. All right. In this case, the slope is the number with the x, and the slope here is 2. Now, slope is rise over run. So if you don't have a fraction there, you want to sort of make it a fraction. So our slope for the first equation is 2 over 1. So I've got to go up 2 and over 1 and then get another point on the line. All right. Remember, you can also go backwards by doing the opposite. Since we went up, if we want to do the opposite, we'll go down. Since we went right, we want to do the opposite, we'll go left. So it's down 2 and left 1, and there's another point. Now, I would suggest, since our solution really depends on us being very accurate, that you plot several of these points using the slope so that you can very accurately draw that line as straight as you can. The other option would be to get a ruler or a straight edge and really make sure you draw that line straight. Since I don't have a ruler, I'm going to use the slope to put as many points on this graph as I can. It makes it easier. So if I'm going to the left to go off the graph, I want to go down to left 1, down to left 1. If I'm going to go up to the right, I'll go up 2, right 1, up 2, right 1, 2, 1. And we can use that slope to see where our line crosses, all right? So there's our first line, and we want to draw it as straight as we can, connecting all our dots. There is the line, y is equal to 2x minus 3. All right, we're going to do the same exact thing with the second equation, but we can stop the minute that line crosses this line, and you'll see what I mean here in a minute. So this tells you where to start. So we go down 1, so that's negative 1. And then there's no number with the x, so that means that the slope is 1, or 1 over 1. So if I go up 1 and right 1, there's a point on the line. Now you can go backwards if you want, go down 1 and right 1. And notice that when you go that way, your lines are getting further and further apart. So going in this direction is going to be kind of a waste of time. We want to we want to plot this second one in such a way that it crosses this one, and then we can stop plotting points. So if I go up 1 and right 1, there's my point. There's where we're crossing. And if you go one more beyond it, up 1 over 1, there would be that line. So you can connect those dots if you want. So there's what this function would look like. plotted on the graph. And now the solution to this system of equations is the place where they intersect. It's this point right here. All right, so basically you just have to figure out what that point is, and remember that that point represents an x coordinate and a y coordinate, so we know that our x and y will be equal to whatever those numbers are. So starting from the origin, we have to come over 2, so that means that our x value is equal to 2. So our solution here is going to be x equal to 2, and then we have to go up 1 to get to it, so that's a positive 1. So the solution to this system of equations is the point 2, 1. You can also say, well, that x is equal to 2 and y is equal to 1. Any way you want to write that, typically you'll see it as a coordinate, but you can also say this. So basically, if I plug in 2 for x and 1 for y in both of these equations, it's going to make both of those equations true, and you can check your work. If I put in 2 here, 2 times 2 is 4. 4 minus 3 does equal 1, which is what y is supposed to equal. Up here, if I put in 2 in this one, 2 minus 1 is 1, and y is equal to 1, so 1 equals 1. So it has to satisfy both of those equations, and it does, so we know we did it right. Let me do another example with you here. So let's plot this point. The y is equal to x plus 5. The plus 5 tells us where we're crossing the y-axis, so I go up 5. There is my first point. All right, the slope here is 1 because there's no number there. That means it's 1. So I can go up 1 and right 1, and I can keep doing that. Up 1, right 1, up 1, right 1. Or I can go down 1, left 1, down 1, left 1. And you can keep doing that as well until it goes off the graph, or you get enough points that you can make a nice straight line extending beyond. So if I keep extending that, it's going to hit the corners of those boxes just like that. So there's my first line. And now I've got the second equation here, y is equal to negative 4x. All right, notice there is no y-intercept here, so that would mean that the y-intercept is equal to 0. So what this means is that this line crosses the y-axis here at the origin. All right, the slope is negative, so we're going to expect our line to go down, slope downward to the right, all right, before we even plot it. But we can say, well, the slope is negative 4, so that's either negative 4 over 1, or we can see it as 4 over negative 1, since the negative in a fraction like that can be either in the top or bottom or to the side. All right, so if we do the first one, that means we're going down 4, 2, 3, 4, and then right 1, because 1 is positive. But notice when we do that, we're getting further and further away from our line. So what we want to do is do the opposite, or look at it this way. We want to go up 4 and left 1. So I've got to go up 1, 2, 3, 4, and left 1. And notice, boom, right there is where it's going to cross. So we don't have to plot any more points. And I'm not drawing my line very straight because I know that this is the intersection of those two lines. So our solution, we can write it as a coordinate. To get to this point from the origin, I had to go left 1. So that means that's negative 1. And I had to go up 1, 2, 3, 4. So my y is equal to 4. You can also say that x is equal to negative 1 and y is equal to 4. All right? So if you have any questions on those, please bring them to class.